Hello everyone. Myself Ankit Patnaik. I'm from Palla Maharaja Engineering College, Barampur. I have done my internship, which is IoT-based home automation. And this internship is provided by an educational tech company, Emertxe. And I have done this project under our ma'am, Mrs. Joylakshmi and Dhanyar. So, in this presentation, I'm explaining about the things which I have learned during the 30 days of this internship. So I have learned about the C and C++ program that essential to build an IoT app, and then introduction to embedded system, introduction to IoT architecture, problem statement, and proposed solution, and requirements of elements in our project, GUI and circuit, working, and conclusion. So in C and C++, the topics that are covered in C languages are basic syntax and data types, operators and arrays, looping functions and pointers, preprocessors, storage classes, strings, and the topics that covered in C++ language is basic syntax, classes and objects, constructors and destructors, oops concept. So now coming to embedded system in our internship, we have just introduced to embedded system. So any combination of hardware and software which is intended to do a specific task can be called as an embedded system. So an embedded system is a specialized computer system that is designed to perform a specific function within a large system. Embedded systems are designed to be reliable, efficient, and cost effective. Embedded systems often operate in real time environments where fast response times are required for safety or other critical reasons. Embedded systems play a crucial role in modern technology and have become increasingly important as the number of connected devices continues to grow. Now coming to embedded system components. So you can find in the embedded system and micro controller or microprocessor, actuator sensor, and DAC, ADC like analog to digital converter, digital to analog converter, and one FPGA or ASIC port, one memory port, one auxiliary system, and one human interface. So coming to sensor, it measures the physical quantity and convert it to an electrical signal, which can be read by an observer or by any electric instrument. And at DC, it converts the analog signal sent by the sensor into digital signal. And coming to the system on chip or microprocessor, it processes the data to measure the output and store it to the memory, and the DAC it convert the digital signal to analog signal, and it send the signal to the actuator, and basically actuator compares the output given by the DAC converter to the actual output and store the approved output. So introduction to IoT. So IoT means Internet of Things, Internet, human to human communication. IoT, anything can communicate using Internet. Collecting information from lots of devices is cool, but it is just telematic. So IoT, the network of physical objects that contains embedded technology to communicate and interact with their internal states or the external environment. So IoT app uses in home, agriculture, automobiles, health and medical industry, and industrial, etc. So now coming to why IoT is important. So in IoT, you can see hardware is getting sick, and by using IoT, we can observe the machine-to-machine communication. In IoT, connectivity is proliferating, software is more advanced, and the cloud cost scale flexibility also can observe in IoT. And the general technical requirements are we can connect many devices to a microprocessor, and we can get large scale of data, and also in IoT the security is also very good, and the data volume also increases, and we can get end-to-end integration on IoT. So the challenges that we are facing on IoT are addressing scale, connectivity, data volume, device size. So for addressing, the solution is pops up. For scale, the solution is cloud, and for connectivity, the solution is queue. For data volume, the solution is cloud storage. For scale and data volume, you can think that both are the same things, and the solution is one, that is cloud storage. And for IoT architecture, the device size should be small or portable. And for this IoT, we mainly use MQP or MQTT protocol, which consume less power. Now coming to the main part, that is IoT architecture. So basically IoT architecture mainly divided into three parts. The first, device connectivity, data processing and analytics, and presentation. In device connectivity, in device connectivity, we can see IP capable devices which is directly connected to cloud gateway, and some non IP capable devices which are connected through a third party, which is a gateway or an IoT client. So now in data processing and analytics, so in data processing, the data is received from IoT device should be analyzed or processed. And now coming to presentation, in presentation, from the analysis or processing of data, the microprocessor should produce some meaningful insight out of it. So the problem statement or proposed solution, the project that I have done. So basically IoT based home automation application I did using Arduino and Blink IoT Cloud. So the solution for is that to build an IoT-based home automation solution, which includes control garden light and water distribution system, monitor temperature and cooler, serial tank control to check water flow level, using Arduino Uno controller and Pixim Lab simulator, which is used to simulating tools and connected by Blink IoT mobile app. So the hardware requirements for our project is one Arduino Uno and one Ethernet sensor, that is ETH5500, temperature sensor module, LED LDR sensor, LCD panel, and PCF 8574. And the software that we require for our project is Arduino ID, Pixim Lab, Serial Remote Tank, Blink IoT app. So here you can see the GUI or the circuit. This is the LCD panel, and this is our serial remote tank, and this is our LDR sensor. This is the Ethernet, you can see, and this is the LED. And Here you can see the Blink IoT app user interface. This is this window for our notification, and here you can see this is for the heater, and this is for the cooler, and here you can see the temperature, you can see like this is a meter where you can see the temperature, and this is for the inlet control, this is for outlet control, and this is where you can see the water level in the tank. Okay, so now coming to the working garden light control, it read the LDR sensor value based on the reading from LDR, vary the brightness to the LED, which resemble controlling garden light based on the availability of sunlight. Okay, so coming to temperature control system, the temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. So read temperature from temperature system, temperature sensor LM35, display temperature on gauge widget, and display temperature on CLCD. Detect the change in the logic level of cooler button on Blink IoT app. If the button widget is at logic high, turn on the cooler. If the button widget is at logic low, turn off the cooler. Detect the change in the logic level of a heater button on Blink IoT app. If the button widget is at logic high, turn on the heater. If the button widget is at logic low, turn off the heater. So read and compare the temperature with 35 degrees. If the temperature is more than 35, turn off the heater and send notification to the Blink IoT app and display the same on the CLCD. So now coming to the water tank inlet and outlet valve control. So by reading the volume of the water in the tank by sending commands through serial communication, display the volume of the water on gauge widget on Blink IoT app and display the volume of water on CLCD. Detect the change in the logic level. If the bottom widget is at logic high, turn on the inlet outlet valve by sending commands through serial communication, and if the button widget is at logic low, turn off the inlet outlet valve by sending commands through serial communication. If the volume of water in the tank is less than 2000 liter, turn on the inlet valve by sending notification to the Blink mobile app and display the same on the CLCD. When the water in the tank is full, turn off the inlet valve automatically and display water level is full at inflow disable. So now coming to conclusion. So the whole things that I have discussed in the working part, I will show you by simulating that. So now coming to the simulation part. So before coming to simulation part, I want to show you my code. So this is my whole program, and now coming to the Pixim lab. So just wait for a moment. So here you can see the LDR sensor, and this is the Ethernet port, and this is the CLCD. Uh, this is the LED, and here you can see when the resistance value is very low in the day, you can see the LED is not glow, but in the night the resistance value will grow automatically, and you can see that LED will glow. You can see the LED will glow at night, and this is the temperature cooler sensor where and this is where we can control it. So you can see when I on the heater. Okay, wait. You can see the in the LCD on is showing and the temperature is automatically increasing. And when we on the cooler, you can see the temperature is automatically decreasing. Okay. So coming to the threshold value, when the temperature is exceeding to 35 degrees Celsius, it will automatically turn off, and a notification will be sent like turning off the heater. Here you can see the turn off message. I will again show you that. Here you can see the temperature is changing, and right after the 35 degree, it automatically off the heater and the temperature is decreased. Okay. So now coming to the water level. So there is a button for outlet valve and inlet valve, and this is the water volume. So when I turn on the outlet valve, when I outlet on the turn on the outlet valve, it gradually decreases, and here you can see the water level on the LCD. Okay. And when the inlet valve is turned on, the water level will gradually increases, and here you can see the water level of that water tank. So coming to the threshold value, when the when the water level is 3000, or the when the water tank is completely filled, you can get a notification from the device that your water level is completely filled. Okay, so you can see when the water level is 3000, here you can see that the turning off notification is automatically came. Okay, now when the outlet valve is turned on and the water level is decreased up to 2000, here you can see the water level is gradually decreasing, and right after the 2000, when the water level is 2000, you will get an notification that is turning on the inlet valve. Means our water level will not reduce after 2000 liter. Okay, so now coming to conclusion, the project is successfully demonstrated, and the application of IoT technology in the field of home automation, allowing users to control and monitor their home remotely. The project uses a combination of hardware and software components, including sensors, actuators, microcontrollers, and the Blink IoT application to provide a comprehensive home automation solution. The project showcased the versatility and flexibility of IoT technology, allowing users to customize their home automation system to suit their individual needs and preference. Overall, the project demonstrates the practical applications of IoT technology and its potential to revolutionize the way we interact with our environment and devices. Thank you.